Imagine a signal leaves Earth, travels thousands of kilometers through space, gets hit by cosmic noise, loses most of its power, and yet somehow it comes back clear enough to carry voices, videos, and data. That doesn't happen by luck. Something inside the satellite is actively keeping the signal alive, fixing what space breaks and sending it back stronger. That something is called a transponder. So, I am Driti, and today we aren't just defining a term, we are understanding the one component that turns a satellite from a silent object to a communication system. So, what is the need of it? By the time a signal reaches a satellite, it is incredibly weak. If the satellite simply reflected it back, the signal would be buried under noise long before it reached Earth again. So, the satellite must do more than just pass along signals. It must actively receive them, strengthen them, clean them up, and resend them in a controlled way. That responsibility is handled entirely by the transponder. Without it, satellite communication would collapse the moment distance increases. A transponder is essentially a receiver and a transmitter combined into one system, placed inside a satellite. Its role is simple to say but critical to execute. It receives the uplink signal from Earth, processes it, and retransmits it back as a downlink signal. The important part is this: the transponder doesn't create information, it doesn't understand the data, it simply ensures that the signal survives the journey through space. Once the uplinks Once the uplink signal reaches the satellite, the transponder immediately gets to work. The signal is first amplified because it arrives extremely weak. But this amplification must be done carefully because amplifying noise along with the signal would ruin everything. After that, the signal's frequency is shifted. This step is not optional, it is essential. The signal is then filtered to remove unwanted components and finally amplified again before being transmitted back to Earth. All of this happens continuously without delay for every signal passing through the satellite. So, one question naturally comes up here: why not transmit the signal back at the same frequency? Because doing that would cause the satellite to interfere with itself. If the uplink and downlink shared the same frequency, the satellite's transmitted signal would overpower its own receiver. The system would become unstable almost instantly. That's why satellite communication always uses a higher frequency for uplink and a lower frequency for downlink. This separation allows the transponder to receive and transmit at the same time without confusion. So, a transponder is built around one principle: preserve the signal by changing only what is necessary. It strengthens the signal without distorting it. It shifts the frequency without altering the information. It rejects interference without touching the actual data. That balance is what makes satellite communication reliable. Some transponders work in a very straightforward way. They simply amplify the signal and shift its frequency. These are often called bent pipe transponders, and they are widely used because of their simplicity and reliability. Other transponders go a step further. They fully process the signal by demodulating it, cleaning it digitally, and then remodeling it before transmission. These regenerative transponders are smarter but also more complex. The choice depends on cost, application, and required performance. Every satellite service you interact with depends on transponders doing their job perfectly. Television broadcasting, satellite phones, navigation systems, and space internet links all rely on these systems operating operating continuously in harsh conditions. If a transponder fails, the satellite may still be orbiting Earth, but from a communication point of view, it's effectively useless. So, when you hear about satellite communication, remember this: the satellite itself is not the hero. The real work is done by the transponder, quietly receiving weak signals, repairing what distance and noise destroy, and sending information back to Earth again and again without being noticed. And that invisible reliability is exactly why transponders are one of the most important building blocks in communication engineering.